last minute questions you guys might have. 3.5, 3.6. I'm dreaming if I think we'll cover it all today, so we will see. In the meantime, just a reminder.
Don't go over there. Stay here. Stay here.
And second, we have a quiz next time, right? That's what we said. The quiz would go up through 3.4. That's what we said. So we have a quiz on Monday.
Next time is Monday. Sorry.
Let's see. Today's the 1st. So we have a quiz on Monday the 6th, right? Which we said would cover 3.1 through 3.4. And then we're going to have our exam on, that's on a Wednesday, the 15th, right? That's what we said? Wednesday the 15th. And that will cover whatever we've covered up to that point. So it'll cover, let's see, chapter 2 was on our last exam, yes? Right? I think up through 2.4 or something. Anyway, it'll cover chapter 2 through whatever we get to. 3 or 4 or whatever. I'll go ahead, I know you guys have been asking, I'll go ahead and set a due date for the chapter 3 homework. The due date for the chapter 3 homework is going to be the day of the exam. So it's going to be due Wednesday the 15th. But please try to finish it before then, because your chapter 4 homework will also be due that day, depending on how far we get into chapter 4. So definitely you want to finish your chapter 3 homework before the exam, because otherwise how could you ask questions anyway? Okay? Kai, yes. What's due on the 13th?
The 13th? Yeah,
Homework. No, it's due on the 15th. Same day as the exam. Wednesday the 15th. Good. Good. Okay. Any questions about the schedule before I move into homework questions? Nothing terribly exciting yet. Okay, cool. Homework questions.
Me.
All right. What do you have?
I have a bunch from 3.4.
From 3.4. Okay, now, only up through 55, right? You didn't try to go past 55?
Oh shit. Yeah, I did.
Yeah, okay. Remember when I said for 3.4 you guys only should be comfortable to go up to 55. If you want to do more, that's great.
Yeah, I
But if
did.
you have questions beyond that, that makes a lot of sense.
Okay, yeah, I don't get it. I went the 65, 69, 87.
Yeah, for sure, yeah.
So 79 through 95 we don't do 49.
No, you're not skipping them. You just didn't, I haven't explained how to do them yet.
Okay, got it.
Yeah. I was
Okay,
really
guys. So much background noise in this classroom.
Sorry.
We are way distractible in here, and I love that you guys want to have a classroom community, but it has to be focused on learning. Okay, so you guys should have been comfortable to go up through 55
Yeah.
based on the lecture notes you had from last time.
Yeah.
We will move on and cover today everything else in chapter 3.4 that we haven't covered yet. So, prior to 3.4, or prior to number 55, did you guys have any homework questions? Yes, Janelle. Number 40? 49. Sure. Yes. Okay, good. So number 49, this is a nice one. It's a nice one twofold. It's a nice one because it's one of your homework questions. It's also a nice one because it's going to allow us to smoothly transition into the rest. So, we are looking at number 49, which is negative 2x cubed times 5x minus 8. So we have number 49, negative 2x cubed. Was that 5x minus 8? 5x minus 8. All right. So what does order of operations say? Parentheses first. Perfect. Is there anything that can be done inside these parentheses? No. Why not?
Because it's a variable and then there's a constant.
Because one's a constant, one's a variable, which is a nice laid-back way of saying that they are not like terms. Yeah, it's a much more colloquial, better way to think about it. But the formal word would be just as equally as good, or that they are not like terms. One variable, one constant. Yes.
So we distribute that, right?
Yes. Good.
So, because we already have it's cubed, right?
Yes.
So does that mean it becomes 2x to the 4th, or negative 2x to the 4th?
Okay. Good. Yeah, I see what you're getting at. Are you guys? So you guys all sound comfortable that we can't do anything else inside the parentheses. Then we move on to exponents. We should do, right? But why don't we do exponents now? Why is Anthony correct that there's no exponent step here? Because there's nothing to do, right? It's x cubed. There it is. It's x cubed. I can't do anything more with it. It's basically, it's already done. There it is. It's sitting there. And then we have to move on to, after exponents, to the multiplication division. And what do we know about multiplication? Multiplication distributes over addition. Or subtraction. Yeah, exactly. Okay, so we are going to take here and we are going to distribute. We are going to distribute the negative 2x cubed into the 5x.
So it's negative 10.
Negative 10 times the 4th.
Cool. All right, good. That's okay. All of you guys have the negative 10 going on. All of you guys know that I'm going to be taking the negative 2x cubed, and I'm going to be multiplying it by the 5x. So when in doubt, just write down the multiplication. There it is, written down. We'll worry about what that means in a second. Now, we know we're also distributing the negative 2x cubed to the
8.
negative 8. So, especially if you guys are unsure, we'll just copy it down. Negative 2x cubed
So the negative 8 is a positive.
times negative 8. Perfect, yeah, and that will give us a positive here in just a second.
Positive
Absolutely.
16.
Yeah. Now, you guys saw right away, you saw the negative 2 times 5, and you said that was a negative 10, correct?
Yes.
Because a negative 2 times a 5, that's negative 10. And then I still have an x cubed times an x.
Is a x4.
Good. Yeah. This kind of ties back a little bit to Vincent's question now from a week ago. We keep getting to use the question because it's a great question. Of these invisible ones. This is technically x to what power? X to the 1. So there's that invisible 1, x to the 1. And when I'm multiplying two, this is what we wrote down at the end of last time, right? If I take two things and I multiply two things, or any amount of things, with the same base, so here x cubed and x to the first, they have the same base, and I'm multiplying them. So what do I do with their powers? Add the powers. Yeah, I add up their powers. So when I multiply, the base gets left alone and the powers get added. So 3 plus 1, so this is now x to the 4th. Good. Good. And some of you had said x to the 4th already, which tells me that you're on top of it. The rest of you, no big deal. Just think about the same base. Means that when I'm multiplying, I add powers. So yeah, Janelle, this is a really nice question because there's lots of layers to it. All right, now let's see. I have a negative 2 times a negative 8. And Allie, you'd already mentioned negative times a negative is positive. Negative times a negative is positive. So this is going to be, yeah, exactly. So this is going to be, whoa. That's unfortunate. Let's see, thank you. Awesome. So first of all, I can do math. This becomes positive. Positive what numerically? 16. Good. Positive 16. And I have this x cubed. Did that go anywhere?
Okay.
Sticking around. Was this really an addition subtraction step between them? Is it okay just to leave the plus?
Leave it plus, yeah.
Just leave the plus. There it is. Yeah. Yes, exactly. So we have negative 10x to the 4th plus 16x cubed. So, cool. What do I do next?
Is it? Right?
That's it. Good. I even hesitated, like, see if I could get you guys to doubt yourselves. But no, you're right. That's it. Good. Why can't I go any further here?
Because it's different, it's like,
Different exponents. Good. Like terms have to have, Anthony, like you said in the beginning, they have to have the same variable, right? If one has a variable and one doesn't, then it doesn't work. Or if they have x and y, different variables, doesn't work. And they also have to have the same power or the same exponent. So we are done here. And we can stop. Now, we're going to try something a little bit different. Were there any more questions about this before I move on? Okay. If you guys think of some, let me know. But for now, we're actually going to try something just a tiny bit